Alright guys, so welcome to our first video and we are going to start the year with the periodic table. So in this lesson we're going to talk about atomic structure, which will be half revision, half new stuff, and the periodic table, how they relate. So what's the point? This is what you should be able to do by the end of this lesson, or what the goal is. By the end of this lesson you should be able to name the subatomic particles and their properties. You should also be able to use a periodic table to identify how many of each subatomic component there is in an atom. Now, remember, so this is the stuff that we should know from previous lessons. An element is a single type of atom. Atoms are the smallest unit of matter that can exist on their own. Okay, so oxygen has just oxygen atoms, but that can be broken down into single atoms, and oxygen tends to exist as two atoms joined together. Isotopes, they have different numbers of neutrons, but they're basically the same atom. So what defines an atom is the number of protons. So if we look over here, we've got proton, 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 just one for each, and each one of these is a type of hydrogen atom. But we'll see that each one has a different number of neutrons. Still hydrogen, because it is the number of protons that defines an atom. Matter with opposite charges attract, so opposites attract, like charges repel. So if we've got a positive and a positive, they will bounce away from each other without actually touching. If we've got a positive and a negative, they will pull in together. All right. So let's look at the subatomic particles. Basically, this is our nucleus. Okay. Now the nucleus contains two parts. It contains a proton and it contains the neutrons. Now, hopefully, by the end of this lesson, you should be able to tell me which atom this is, particularly if you've got a periodic table in front of you. So, let's have a look at the protons first. They live in the nucleus, they have a positive charge, and they've got a size of 1 atomic mass unit. Okay, now that's based on basically the size of a hydrogen. Neutrons, they live in the nucleus. They have no charge though, they are neutral. So they have no charge at all. Now, their size is also an atomic mass unit. They're actually a little tiny bit bigger than a proton, but that doesn't matter for us. Then we have electrons. And electrons are these guys. Now, these guys are constantly moving at almost the speed of light. They whiz around the nucleus in a shell. So electrons move in shells around the nucleus. They have a negative charge, which means they are attracted towards the nucleus here. We'll talk later on about why they don't crash into it. And they're very small. They're about 0.0005 of an atomic mass unit, or 1/1800th. It's actually 1850th the size of a proton. Now, the periodic table, we can get all that information for any atom we want from the periodic table. Basically, the periodic table is a way of organizing elements according to their atomic properties and their physical properties. The atomic property we use to organize them is their number of protons. So element 1 has 1 proton. Element 2, 2 protons. Element 17, 17 protons. Now, it organizes the elements in ways that their properties form repeating patterns. So to go up, like, for example, the electronegativity. So the ability to pull an electron off something else. It will increase, and then go back to almost zero, and increase each time you go down. We'll talk about that in a second. Now, a large amount of information is stored on, or can be derived or pulled from the periodic table, and it looks like this. So we've got all of our elements here, including a bunch which haven't been discovered, although some of these have been discovered now. So we've got all the elements here. They come down here. This is actually, this whole long row fits in that block there. And each one of these groups has a different name and a different set of properties and so forth. And as we go through, we'll learn how to read this table and how to use it effectively. Now, here's the elemental symbol. Now, the elemental symbol itself is the basis for our information. For example, You've got the H in the middle, which is A, okay? So you can actually draw it like this, and you go Z. And so it's A for atomic symbol, Z for atomic number, M for mass. So the atomic number for hydrogen is 1, and its mass is 1.01 atomic mass units. Now this is the average mass of all of the hydrogen atoms. They do vary, and that's because we have isotopes. Alright, so this is how we read it. So the atomic number, so this is, we've now moved on to lithium, which has an atomic number of 3 and the atomic mass of 7. Basically, the bigger number is always the atomic mass. So the atomic number is how many protons it has, and each atom has the same number of electrons. So atomic number, so Z equals protons. Now, because they've got a mass of 1 and neutrons have a mass of 1 and electrons have a mass that we can almost ignore because it's so small, the atomic mass is actually the number of neutrons plus protons, which we'll see over here. So, again, we're still on lithium here. So lithium, now there are several ways we can write this information. Where's my pen? So the atomic number is the number of protons. The mass number is the number of protons plus neutrons. In the case of lithium, it's usually 4, so we go 7. Lithium is the elemental symbol. Here's the symbol with the mass number, symbol with the atomic number. We put them all together, and that's our subatomic particle composition. Now remember that 3 is also the number of electrons. Now here are two ways to draw it. You can draw it very simply down here. We write 3p, 4n, and then you put the circles around with the dots for the electrons. Or you can draw it like this. This shows how many protons are there, how many neutrons are there, how many protons, and how many electrons. And that's the other way to do it. This is a much more detailed way to draw it, but when we get to very large elements, it can actually be quite cumbersome and almost not worth doing at all. So here's the summary. So we've got atoms. They have neutral neutrons, positively charged protons. And if you put these two numbers together, you get the mass number, but the protons gives us the atomic number. They have negatively charged electrons. This number may differ, and if they do, they become these things called ions, which we'll talk about later on. If this number differs, we get isotopes. And that's it. So I hope you took your time, took lots of notes, and we'll see you in class.